Hello and welcome to Slack Chat Season 2, Episode 20. I'm Stuart Winter, the Slackware ARM architect and platform developer. And with us, we've got Brent Earle, who's been helping with the port to the ARch64 platform. Hi, Brent.
Hello.
How are you doing?
I'm doing okay.
Good stuff. It's been about two
months
before, since we last spoke and did the last podcast with the Raspberry Pi. So the good news is there's been a lot of progress. As you know, I've released the Pinebook Pro installation guide, although admittedly, I actually didn't mean to do that because it was supposed to be private and I made it public because of publishing the Slack chat episodes. And then I suddenly realized that I made it public. But anyway, that's out there. And the Raspberry Pi 4 support is pretty much complete as well, thank you to you. So I took all of your work that you'd released and merged it into the new build system. Yeah, the only thing I haven't done right now is the documentation for the Raspberry Pi. So, but it's really easy though, because basically I'm going to pretty much copy paste the Rock Pro 64 and just change a few screenshots. Do you know what, Brent? I've realized admittedly I had your work, your integration work, the R&D work you did to just use and integrate. So I already knew that you got the installer and the OS booted. Yeah. But to be honest, it was the easiest integration I've ever done.
There's not much to do really.
No, I just took all the bits. I just, changed the SD card builder and a U-boot builder a little bit. Yeah, and it took me about an hour, all in all, to merge it in. And then I booted it. Oh, well, I booted it with the latest version of U-boot for 2022. There's a release candidate I was using on the Rock Pro 64. So it all works on the Rock Pro 64. But on the Raspberry Pi, it boots the kernel, but it can't find the OS in it. Well, it can't find any initial RAM disk. And I wasn't sure if it was a kernel problem. But then I realized that your old, the installer image that you'd made, that had an older version of U-boot. So I reverted to the latest stable release, and it works on the Rock Pro 64 and the Raspberry Pi 4. So that was convenient because I was thinking, oh God, is it a kernel problem? I'm gonna have to go and figure out why what's going on. But no, it wasn't.
That's good. It wasn't a kernel problem. That would have been a pain in the butt.
Yeah, but luckily it wasn't. So I've got all of that done. In terms of testing, you do need to update your bootloaders on them because on the Rock Pro 64 and the Pinebook actually, because I upgraded the version of the ARM trusted firmware and it had a few patches.
I did that on the Rock Pro already. I have to do it on the Pinebook yet.
Yeah, although that USB booting thing, the pre-boot USB, so you can access the U-boot console with a USB keyboard, that still doesn't work. Well, it didn't work in the latest RC, but. Yeah, so it hasn't really caused an issue though that you can't interact with it.
No, if you remove the installer during installation from the SD card, it doesn't. No one will have any clue really.
Yeah, but you can still control it over the serial port, so it still works. Right, so there's something that I was just doing. I forgot to mention that this humming noise is from Brent's side, and it's his Raspberry Pi that's joining the podcast. Is it the fan on there? That's.
I have Thunderbird compiling.
Oh right,
it's
okay.
Doing it over the network.
Oh yeah. That's the only package that is not currently building in ARch64. So So thanks for looking at that. There's only another one actually that I know that's broken, which is Emacs Speak. The package builds, but it is missing the actual audio library. I can't remember what it's missing actually, something like that. So I need to fix that one as well, although it's not exactly top priority. But other than that, everything is ready to go, which brings us to the installer. So what I've done is, I'll tell you what, let's boot this up first. So what you're going to see here is the Raspberry Pi 4 booting. So I'm just turning it on. I'm connected here over the serial console to it. Should boot in a moment. There we go. RPI 4. And now it's booted U-boot, and it's going to boot the Slackware OS. So I've got the Slackware installer working on the Raspberry Pi 4, and I've got the way I'm going to document it the supported installation configuration will be the same as the Rock Pro 64. So you use well, in the case of the Raspberry Pi, you use a USB to SATA converter and connect the SSD or whatever onto that.
Yeah.
Because that makes the most sense to me. I mean, you were saying earlier, weren't you, that some of your SD cards just die, don't they?
Yeah, I hadn't used a few of them for a while, and then I just plugged one in and just said I/O error over and over. So,
Yeah, that's what I found. All of these removable media cards, they have a very short lifespan. So I really strongly recommend that people do not use the SD card to house the operating system, particularly the root file system, and certainly don't put swap on there, because you'll just wear the things out. They have a very limited lifespan in my experience. But what we're using them for in Slackware is just the boot partition. So it contains the kernel, the initial RAM disk, and in the case of the Raspberry Pi, there's another partition, a fat partition, that contains the Raspberry Pi boot code. And it also contains a second stage U-boot loader as well that we use to boot Slackware. I think, though, for the boot partition, it makes perfect sense to use an SD card, and it makes it, in the way that it's been done for Slackware, well, for Slackware AR64 anyway, is that the boot partition on all of the supported hardware models will be on the micro SD card or the SD card for the board, because that's a pretty portable way. For the Raspberry Pi, we've not done a lot really, Brent, have we, to make it work? It's just it's basically the Rock Pro 64 support with some extra stuff in it, and it just works. So it's a really portable way of getting Slackware onto new hardware models. And I think that in terms of the longevity of the storage, I think it'll be fine because there's a very limited number of read-writes on there. As I was saying in the previous podcast, when you go to install Slackware, it asks you if you want to resize the boot partition. And I actually don't want people to be encouraged to put files on there. I actually want to discourage you from using the boot partition for anything other than booting the device, or the hardware model, and booting Slackware, because I'm just concerned about the longevity of the storage. And obviously, to me, I'm a systems operations guy, so I want the systems to be working. I want them to have a good life. So that's why I really strongly encourage people to use an SSD or something like that, or NVMe as well. We've got that on the Pinebook Pro, don't we? So Brent, what we can see on the screen. So this is the Slackware operating system initial RAM disk, and for my build machines, I always add this await root dev. It's a kernel command line operator that instructs the Slackware OS init to wait for the root file system to come online, instead of just erroring out saying I can't find the root file system. The reason that that's in there is because sometimes it takes storage, particularly spinning disks, some time to spin up. So we just keep waiting for them to arrive. And in this case, you can see that my root file system is not coming online. And the astute observers amongst you will say, well, isn't MMC an SD card? And you just said, don't put your root file system on an SD card. And if you were thinking that, you'd be right. That is exactly what I've done here. And to be honest, I just couldn't stop myself. I just was really curious as I was preparing to write the documentation for the Raspberry Pi. I was just really curious, can you actually install Slackware onto the micro SD card and boot from it? Because you should be able to do. I've just been fixing a bug in the probe tool within the installer that discovers the devices available, because it had a bug when it was discovering MMC, so it wouldn't find some of the MMC devices on the system. So I was fixing that, and I just wondered, can I get Slackware to boot from the MMC? Although I'm not recommending it, but I was just curious if it worked. And as you can see, it doesn't work. I did manage to install it within the installer, but booting it, this is what's happening. So what we need to do, I know that given that I know that this works in the installer, it must be just that there's a missing module or something like that. So I think what I'm going to do is I'm going to boot back into the installer on this machine. So I'm just going to turn it off. So, oops. Yeah, there we go. And then I'm going to get a Slackware installer image and pop that in the Raspberry Pi. Okay, and then turn it on again. So again, the display that you're looking at is from the UART, so the serial port. So I'm just SSH'd into one of my Slackware laptops, and we're just looking at what's coming over the serial port there. So it's just booted the second stage U-boot bootloader off of a fat partition on the micro SD card, and now it's booting the Slackware. It's booting the Slackware installer image. So the installer's booting, and there we go. You can see the MMC block 0 devices there. I thought this might be a good way of showing how you can get, how you can work with getting Slackware on other machines when things don't quite work out properly. Okay. So what I'm going to do is block. What do we have? Yeah, so you can see the MMC block 0 is here. So what I'm going to do is mount //q. So I'm just going to mount my NFS server that's got the Slackware stuff on it, and I'm just going to run this script. Ooh, that doesn't really fit on the line that well, does it? That doesn't matter. dev/MMC block 0. And what this does, let's pipe it into less as well, actually. This lists out which modules are involved with particular devices. Okay. So I already know that the MMC BLK module is loaded because it's there for the Rock Pro 64. So I think that it must be something more of a platform level where it doesn't have the whatever the driver is for the MMC controller on the Broadcom, whatever it's called. What is it? The BC?
BRCM or BCM?
Yeah,
2711.
Oh yeah, that's it. Yeah, so I guess we don't have the module for that in the operating system initial RAM disk. So I reckon
it should have it. I don't know. It's been a while since I looked at that, so I don't remember exactly what the module names are.
No, I don't know. I took whatever you gave me, put it in there. I'm gonna try this one because I don't think that one. Yeah, that could be it. Yeah, so if I mount. Okay, I know what I'm gonna do. I've actually got space left on the USB bus of my Rock Pro 64. Yeah, I do. I think. Let's see if
I think though, if people want to install it on an SD card, they should use the flash-friendly file system. That'll speed things up too. Yeah.
Yeah, well, still not sure I'd exactly recommend using one.
No, I wouldn't. I'm like, if you had no other option, yeah. But.
Yeah, I mean, I want it to be technically an option though, because people, if they want to use it without doing, without updating the system frequently, or I mean, I certainly wouldn't advise putting Slackware Current on this because you'll wear it out pretty quickly with the updates.
Oh, no.
But for a stable release, if you're not running swap and aren't logging anything, I mean, yeah, that should be okay actually on an SD card, I reckon. But certainly not for my use. I kill them off with all of the building work and everything like that. Oh. Right. So what I'm going to do here. So I've just Pepper is my Rock Pro 64 that sits on the desk, which is like my stunt. It's like my stunt car for ARM boards. It gets to do it's like a crash test dummy. It gets to test things out where I don't end up ruining the primary build machines. So I'm going to mount the STB2. I'll tell you what. STB2 floppy.
SDHCI_PLTFM platform. There's that, and that should load all the SDHCI stuff, the kernel modules.
So I've got two SD cards. The one that I just booted on the Raspberry Pi was a different SD card that just had the Slackware installer on it.
Oh.
And the one that I've just mounted here on the Rock Pro 64 is actually the Raspberry Pi's SD card. So it's been set up in the installer and it's got the root file system on the third partition. So I've just mounted it so I can change its bootloader config. So what I'm going to do, I'm going to put in, is it SLK PBS, isn't it? I'm going to boot the OS into the Slackware development shell and then figure out what the module is. I think that's probably the easiest way of doing this. So I'm gonna, yeah, there we go, sync. So if I extract that from there, and so that's the Slackware installer. And then if I take, I've got like so many cables and stuff. It's like with these different machines,
Yeah.
a lot of stuff. Ideally, I could tidy it all up, but yeah, go around to that, I guess. Okay, right. So let's just reboot that. So reboot the installer, and we should get it booting into the Slackware pre-boot shell. So there's U-boot loading. Okay. Okay, so at the moment there shouldn't be any modules yet. There's probably nothing. Oh yeah, it's got the static device. It's in there. Okay, so we don't. The first stage, I don't need that. Let's go into the second stage. So the Slackware kernel module loader is loading these modules. All of these modules are configured within the operating system initial RAM disk. Ooh, there we go. In here. So there's a script called load kernel modules, which processes all of the plugins here. So basically, this the Rock Pro 64. I can show you actually on here. I know that you know this, Brent. I saved it for the podcast.
Yeah.
So the way that Slackware works on ARM is that it works with the plugin system. So you define your board's configuration in these files here. So this one, for example, is the Raspberry Pi 4. This is the Raspberry Pi 3. Is it the 3? I don't know.
Yeah,
and
I think it is. Yeah.
Yeah, I did always wonder why the Raspberry Pi 4, why the SOC, so the chipset number was less than that one.
Yeah, I don't know.
Don't know.
I'm sure somebody knows on the forums though.
Probably, I'm sure somebody knows. And this, the RK3399, is to support the Rock Pro 64 and the Pineboard Pro, and maybe some others actually from Pine 64, which can be expanded in time. So that's basically how it works, so both on the kernel module loader side, but also in the build system for the SD card builds and the U-boot builds and some other things. It has basically this plug-in system like that. And the structure's pretty much the same, pretty consistent. Okay, so where are we? Okay, so we've got the modules loaded at this point. So what we've done here, so I've added this kernel command line parameter called SLK PBS, which is just for Slackware. And what that does is it has two stages that you can insert yourself into the boot process. So it opens up a shell at two stages. The first is before it loads any modules at all. So that allows you, for example, if a module is loading that's crashing the system, you can start exploring the system, you know, from zero. So you've got no modules loaded and you can start playing around there. It's probably not the most useful stage, which is why I immediately exited it. And the second stage is after the module lists have been processed and the hardware platform configuration has been processed and all the kernel modules have been loaded. And this is the interesting phase for me because this is, you can see, and there's no MMC devices. So DHCI.
Yeah. And then I think it's, let me find, I'm looking on my Raspberry Pi, underscore iproc. Not a dash, but an underscore, I believe.
Oh yeah, you can use dash here with this.
Oh, okay.
Oh, that, yeah.
That was it.
No, there we go. That's it. Look, it is that one.
Yeah.
So that's okay. Right. So that now has brought up the SD card. So if I'm going to make a copy of that. Just a sec. Paste it in there. Right. So if I exit the pre-boot shell, just do Control and D on the shell to exit. Oh, there we go. Oh, there we go. Yeah, it's booting. Oh, what happened to that? Oh, it just
Can't find MMC BLK1. And you have it set to for 0 instead of 1.
yeah. Hang on a minute. You must have done something else to it when I edited it.
Probably FF fabric, yeah.
Oh, I know what. Yeah, because I was fiddling around with it. Okay, that's why. It is that. Yeah. Oh. Oh. Ah.
Try to remount it.
Slash. Okay. Yeah, that's what it is. Oops. Ah, the
You have a
kernel.
0.
The kernel is spewing out driver messages there. Oops, hang on. Stop it. Okay. Oh, hang on. That's gone completely wrong now. Hang on. Do that again. Oh, oh yeah, that's that Bluetooth.
Doesn't like the Bluetooth.
No, you've got to figure that out. Okay.
The Bluetooth is something that changes as they make changes to the Raspberry Pi boot codes. I don't know why they make changes, but it stops working sometimes. Sometimes it does work.
Okay.
Depending on what version of kernel you're running and stuff. So.
Okay. I have to do a force. Oh yeah, when you're inside of here, you typically have to do a force reboot because the system won't always reboot. Right.
Yeah.
You don't in the installer or in the OS though, once it's booted fully. Okay. So let's see what happens now. Oh, I'm gonna have to load the module again, aren't I? Okay, let's exit the first. Just don't exit this time. Okay, mod road. Okay. Well, hopefully it'll boot. Oh, hold on a minute. Now it's come up as MMC. Okay. Now it's appeared as BLK1, whereas previously it was BLK. I'm just going to turn it off.
Yeah, completely power it off.
But that's something there. That means that you can't rely on the number, the block device number being the same every time.
Well, I think it depends on when the module's loaded too.
Yeah.
So.
Yeah, that's a point. Yeah. Which, well, yeah. Even once I put the module into the bootloader, into the kernel module loader, that it will be loaded in the same order, but that doesn't guarantee in the future that something else will change.
Yeah.
So, yeah, it doesn't have that problem with SDA with the SCSI drives or the
Yeah, no, that's why I've just been installing to my USB drive.
Oh yeah, look, it's BLK1 again. Yeah, let me do that because it seems to be wanting to be BLK1 now, right? So, so hang on. MC. Oh. P2. Yeah, it's Q. Oh. Yeah,
I think it's 3.
Okay, so let's replace that with that. Yeah, that's right, isn't it? Okay, and then replace. Oh, it's not bash, is it? Mount P3. Just add put it back to 1 again, shall we?
And then U-boot will boot, but then the OS won't find the disk probably.
It's all no. It's all going to work. Trust me. Okay, let's give that a go. Actually, does it reboot without Basher? We'll find out. Maybe it does.
Not in the preboot.
No, it doesn't. Oh no, that's right. The preboot shell definitely doesn't. Maybe I'll update the preboot shell to do a wrapper. No, I won't do actually. Well, maybe I will actually. These are the kinds of things I find I struggle to control myself. I just have to go and do every detail. But you know, that's part of the fun.
Yeah.
Right, so I'm still going to have to.
Actually, it's consistent if it's disk 1 because it looks like U-boot sees it as disk 1 instead of disk 0.
Yes. Oh, I know. Yes, I noticed that too. Yeah. Okay. Yeah, that's stage 1, isn't it? Oh yeah, I remember when we did a podcast before, and I didn't know which bootloader stage it was, so I added in the stage number now, so we can go off talking and then return back and remember where we were. Mod probe. Right. Let's load that. Yeah. Okay. Let's exit. It's going to work now, Brent. Guarantee it.
Crossed.
Guarantee.
It's going to say that it's going read only. The file is corrupt.
Oh, we might do that. Yeah. You're so positive. So it is booting. In fact, it's working. So what we're going to look at, not on this podcast, but this needs to be looked at before the release, is what is holding up starting Bluetooth there. I don't know if that's a firmware issue. I haven't looked into it yet. I need to update the. Well, actually, I was thinking about this. Let's have a look while that boots. Oh, 64. Okay, so that's what was that module name again?
SDHCI underscore I. Let me see.
That's it. SDHCI iProp. Yeah, that's the one. So what we're looking at here is the script for the Raspberry Pi 4 that's included into the kernel module loader when it boots. So at runtime, it loads all these scripts that I talked about before, and this is the one that sets the modules and does anything else you need for the Raspberry Pi support in order to light up that system. So what I've just done here is I've just typed in the name of the driver for the MMC on the Raspberry Pi 4. I think they're called IP cores in ARM terminology, but so that's what I've done there. So I've just added that in here. So the next time I rebuild the installer and the kernel, that will be able to find the MMC storage within the operating system initial RAM disk. So it will actually just be able to boot from an MMC. Although as we've been looking at, the number of the position of where it is on the storage bus, if that number is inconsistent, then that's not going to be particularly conducive to being able to boot your machine with any kind of regular cadence and without you having to interject. So that would be something we'd have to have a look at some point in the future. But if I rebuild the kernel, that will fix that for the next time I install. Although again, I still don't recommend anyone boots. I don't recommend that anybody installs the OS on a micro SD card or an SD card, but I don't want to prevent people either. Right. So this is the this is the Raspberry Pi 4, and you're looking at this over the serial port. We can see there TTYS1. So if I log in, I'm just going to check. SDHCI, just double check. I just want to make sure that I've exactly got it right before I recompile the kernel. SDHCI and iProc, yeah, that's the one. Okay, what I'm going to do actually. Oh no, I'm not going to compile a kernel on Pepper because that's the one on my desk. The fan doesn't speed. I'll build it on one of the build machines. Cool, yeah, so this is the Raspberry Pi where its root file system is on the MMC, on the micro SD card. So the Raspberry Pi for support is pretty much done. I think the Wi-Fi works. I wasn't sure because I was testing it on the Rock Pro 64 and I got the Wi-Fi tested there. And I couldn't remember if I'd done it on the Raspberry Pi, but yeah, the Wi-Fi works. I don't know if the sound works. Certainly the Bluetooth, as you saw, that's got some issues, so I need to figure that one out. Goodness.
I believe when I tested it a while back, the sound was working
Okay.
over HDMI, but
Okay, cool.
I never used the audio jack, so.
Okay. I'm not too concerned about the sound at the moment. That's kind
Yeah.
of sort of tertiary thing. This is the Slackware kernel firmware package. So for Slackware ARM and AArch64, it's basically the same kernel package as in Slackware x86, but I'm including any hardware model firmware into it as well, rather than having, say, a Rock Pro 64 firmware package and a Raspberry Pi firmware package. So at the moment, I'm just bundling it all into a single monolith that is the kernel firmware package. So again, we've got the same plugin system inside the source tree. So if you're interested, and we'll do a different video on this at some point in the future once I've written the exposition of direct integration guide for Slackware ARM. I'll probably do that soonish, I guess. I'm not sure, but where are we? Yeah, so it's the same thing. It's a plugin system here. So in this case, this is the Rock Pro 64's one. So you simply got a file that downloads the firmware package, which is the one that you did, Brent. This is the one you did for the Rock Pro 64 firmware, and then what's that? Oh yeah, this is a plugin script, I think. Let's have a look. It's been a long time since I wrote.
I haven't looked at any of that in months.
No, me neither. So in the same way as the Linux kernel module loader that we've been looking at, that walks the file system under a particular location looking for scripts, and it includes them and runs them. They're all bash shell scripts. So you've got the full flexibility of the shell to do whatever you want to do to bring up the system. If you're going to be submitting some of this stuff to me, then I'm going to be, judicious over certain things. But really, what's in there is for the Rock Pro 64 and the Pinebook Pro and the Raspberry Pi, and also what you're working on, Brent. Which one's that one?
The Orange Pi R1, I think. Okay. I forget which version of it, but it's the newer one.
Okay. So with those ones that you see integrated, you'll be able to use those as reference, because it's a lot easier to just see what's been done and how it works, and you probably have to change very little for other hardware models. So again, yeah, so what we're looking at here is this build script. This is actually the script that builds the kernel package, the kernel firmware package, and it includes these scripts. So as you can see, we only have one for the Rock Pro, or for the RK3399. So I don't know if we need to include some additional firmware actually for the Raspberry Pi 4. So I think that's something I need to look at.
I think it's all included in the blobs in the boot directory, pretty much, as far as I know, and then the rest of it's in the kernel already. So kernel modules and stuff. Let me see.
Okay.
I can't remember. Hold on.
The thing is, though, oh yeah, let's have a look at this. So on the Raspberry, so in the Rock Pro 64, the way that it boots off SPI flash, whereas on the Raspberry Pi, and actually this is easier than the Rock Pro 64 by a long shot, actually, is that the micro SD card's first partition is a FAT partition. And so this is what you're looking at here. So this directory here, /boot/platform/HWM_BW, where HWM means hardware model and BW means bootware. This is where the Raspberry Pi bootloader is. So for those of you who are familiar with Raspberry Pis, you've probably seen /boot populated with this kind of stuff. So I've pared this down to pretty much what I can get away with, just to chain load U-boot, from which we'll boot the Linux kernel and Slackware. So the reason I'm saying that is because this is probably quite a departure from what I think most people have seen in other distributions, but I think it's really good, particularly because it means we can easily use U-boot. And then we've got a harmonized and standardized way of booting and managing the boot configuration within Slackware on the ARM platform. Well, at least on the ARch64 platform. I don't plan on migrating the 32-bit to this. I think it's too much work for little reward. But yeah, certainly on ARch64, I love it. I'm absolutely loving using U-boot with the X Linux support. It's made it so easy to write scripts that just change the config. It's amazing. I wish I would have had it on ARM 32-bit, to be honest. But yeah, the other reason I'm talking about that. So also in here, I'm not sure that any firmware that you'd have in here would make it into the Linux kernel, because this stuff is certainly not going to be accessed from within the OS, because there's nothing that knows of the presence of anything within this directory. So that's where my knowledge of what the Raspberry Pi bootloader does comes to an end. I'm not sure if anything, anything is going to make it from the sort of initial bootloader into the second stage. Well, actually, I tell a lie. It's not the initial bootloader, is it? Because that'll be something else, which then boots the bootloader off of. Oh no, it would be actually.
There's actually is an SPI flash on the Raspberry Pi, but you're not supposed to change it, and that's what bootcode.bin accesses, I believe, and then the rest just kind of chain loads off that, and then loads U-boot. So it's kind of like a handoff.
I would have thought it would be the other way, where it boots off of the SPI flash initially.
Yeah, it uses the SPI flash, and then it goes to use the bootcode.bin.
Yeah, okay.
And then starts U-boot. Yeah.
Right, okay, that makes sense.
Yeah.
Right, okay. Yeah, so I'm not sure that having any firmware in here, even if there was really any, which there certainly isn't for Bluetooth or anything like that. No. I'm not sure that would make its way into Linux anyway, but I don't know much about that domain. My guess is, well, the other thing is that some of the Raspberry Pi, well, not the Raspberry Pi, but the BCM 2711 chipset, I think is already included in the Slackware standard kernel package from I think we get the kernel firmware from kernel.org, if I remember rightly.
Yeah.
But I think it's already in there. So.
Yeah, I think a lot of the stuff was added in 5.13 and 5.14 kernel. Yeah, that's the stuff.
Yeah, this is for a different chipset.
Yeah.
And probably there's nothing beyond that, because that's probably BR is Broadcom. Yeah, oh yeah, it will be BR CM Broadcom. Okay, right. So I probably need to add in some kernel firmware there. I don't know. I'll have to figure that one out. Cool.
Maybe. Yeah.
All right. Well, and that won't take too long. And then hopefully that will fix the Bluetooth issue.
Yeah, I'll look at it today. It looks like Thunderbird's going to make it, so.
Oh, cool. All right.
It's actually compiling Thunderbird now instead of just all the Rust stuff and cargo and all that.
Oh, yeah. It takes a while. All right. That's cool then. So what I'm going to do, actually, is reinstall this Raspberry Pi. And as I do so, this time install it onto the SSD. And take some of the screenshots for the documentation, and then it can start finishing off the the install documentation for it, and maybe make a video for it as well. And that's probably pretty much it, I reckon. I'm not going to release it until after Slackware 15 is released, though, because I've got quite a bit of other stuff to do.
Yeah.
And every time I change if I change any of the kernel loader, the core script that contains the sort of base platform for both platforms, I have to go and retest it on ARM as well, or include the kernel module into the ARM build as well. So I don't want to give myself too much work at the moment. Right. Right, cheers, man, Brent. I think that's as we've moved it on a bit more now. So I reckon probably in January 2022, I can release Slackware ARH64 into the wild.
Very good.
And then I know there's quite a few people have reached out to me about testing it. So I need to get back to those guys and set them up with the private repo access as well, so we can do a little bit more testing before making it live in January.
Perfect timing too with the holidays. People have time. So.
Yeah, exactly. All right, man. So let's close this podcast, and we'll see you on the next one. Take care, Brent.
All right, see ya.
Yes.